Okay, today we will discuss about hydrolysis of salt formed by strong acid and weak base. In the last lecture, I have given examples for salt formed by strong acid and weak base. Okay, just I'll brush up. Say for example, ammonium chloride, ammonium nitrate. Plenty of examples are there. Anilinium chloride, okay, anilinium NH3 plus Cl minus, anilinium hydrochloride. Okay, like this we have plenty of examples for salts of strong acid and weak base. See here, ammonium chloride is formed by the strong acid HCl and the weak base ammonium hydroxide. Okay, when HCl react with ammonium hydroxide, we get this salt, where HCl is a strong acid, ammonium hydroxide is a weak base. Okay, so this is a salt of strong acid and weak base. Now what we are going to do is we are going to discuss about hydrolysis of these salts. Okay, right. So how this salt undergoes hydrolysis and how to calculate the hydrolytic constant for the salt, and how to calculate pH of the solution. Okay, yeah. So for example, I'll take ammonium chloride, right? I'll take ammonium chloride as an example, then we'll discuss, right, based on that. Okay, see, ammonium chloride solid, when you dissolve in water, okay, it will undergo complete dissolution and goes to aqueous solution. In the aqueous solution, ammonium chloride in aqueous solution undergo dissociation. It undergoes ammonium chloride in aqueous solution undergoes complete ionization, because ammonium chloride is a strong electrolyte. It undergoes complete ionization or complete dissociation, gives ammonium ion in aqueous medium and chloride ion in aqueous medium. Okay, so you will get cation and anion from the salt, and you know very well cation always comes from base. Ammonium ion comes from ammonium hydroxide base. Okay, ammonium hydroxide is a weak base. See, ammonium ion comes from ammonium hydroxide. Ammonium hydroxide is a weak base, whereas the cation that is obtained from ammonium hydroxide, that is actually a strong conjugate acid. I repeat, a base will produce a cation, okay, and that cation is a conjugate acid. If the base is a weak base, the conjugate acid should be strong, right? Similarly, this HCl is obtained, chloride ion is obtained from HCl. HCl is a strong acid. Okay, acid will produce anion. That anion should be a conjugate base. I repeat, acid produce anion. That anion should be a conjugate base. Since the acid is strong here, the anion should be the weak conjugate base. So here chloride ion is a weak conjugate base. Okay, Ca means conjugate acid, Cb means conjugate base, and I told you in the last class that strong conjugate ion react with water. Okay, since this salt produces strong conjugate acid, so this salt undergoes hydrolysis. if both are weak, if both ions are weak conjugate acid and weak conjugate base, then those salts do not undergo hydrolysis. That we know very well. Okay, since ammonium ion is a strong conjugate acid, it will react with the water and hence the salt undergoes hydrolysis. Okay, yeah. So in order to understand this, we'll proceed like this. For example, I'll take 1 mole of ammonium chloride. Just for understanding purpose, I'm taking like this. You take 1 mole of ammonium chloride solid, dissolve in some amount of water. Okay, dissolve in some amount of water so that you will get a solution. Okay, and this solution have some concentration. Let the concentration of the salt be C. Okay, remember C is the concentration of the salt. What is concentration? Number of moles of ammonium chloride present per liter, right? In molarity, right? Concentration is in molarity. Now this salt, the salt that is we have added, okay, it undergoes hydrolysis in solution. Okay, what actually happens? I have told you ammonium chloride dissociate to give ammonium ion and chloride ion in solution. Okay, if the concentration of the ammonium chloride is C, since ammonium chloride is a strong electrolyte, it will undergo complete dissociation. So one ammonium chloride molecule will give one ammonium ion and one chloride ion. Therefore, if concentration of ammonium chloride is C, then the concentration of ammonium ion in solution should also be C, and the concentration of chloride ion in the solution should also be C. Okay, so this is the first point you should keep in mind. Now these ions, see, I have told you chloride ion is a weak conjugate base, so it does not react with the water, whereas ammonium ion is a strong conjugate acid. Okay, stronger conjugate ion will react with the water. So ammonium ion reacts with the water here. Ammonium ion, okay, reacts with the water and undergoes this reaction. Okay, what happens here? You split water as H plus and OH minus, right? Ammonium ion combine with OH minus and form ammonium hydroxide. We get ammonium hydroxide and this H plus ion is released. Observe this carefully. This conjugate ion reacts with the water and produces H plus ion in solution. That is the reason why the solution become acidic. Right? Why the solution become acidic? Because this salt is a salt of strong acid and weak base. You know very well, the stronger ion decides the property, or the stronger part decides the property. Since the base is weak and acid is strong, so this salt, if you dissolve this salt, this type of salt in water, the solution become acidic. Okay, yes, it clearly, okay, we have proved it clearly here, right? This ion on reaction with the water produces H plus ion, therefore the solution become acidic. So that salt, so this salt should be an acidic salt. Okay, now see what is the, suppose if 1 mole of ammonium ion reacts, for example, suppose if we have added 1 mole, we have taken 1 mole, but not all the ammonium ion will react with water. From 1 mole, some moles of ammonium ion will react. Say for example, H moles of ammonium ion reacts. Right, you will get H moles of ammonium hydroxide and H moles of H plus ion, because one ammonium ion will produce one ammonium hydroxide and one H plus ion when it reacts with the water. Okay, now what is the concentration of ammonium ion at equilibrium? See, initial concentration of ammonium ion is C. This is initial concentration, but now due to this hydrolysis reaction, ammonium ion concentration in solution at equilibrium is not C. What is the concentration now? Now the equilibrium concentration now is 1 minus H into C. This is the concentration of ammonium ion in solution now. Okay, similarly, what is the concentration of ammonium hydroxide? HC. And what is the concentration of H plus? HC. right? Since the concentration of ammonium ion is C, right, before undergoing hydrolysis, right? So to get the equilibrium concentration, we have to multiply this by C, this by C, and this by C, right? Now, since there is an equilibrium, okay, we can write the equilibrium constant, right? Water is involved, therefore I'll put directly KH. What is KH? KH is nothing but hydrolytic constant. Hydrolytic constant, okay, hydrolytic constant of the salt. This is K. This is nothing but KH. How to write KH? See here, in this case, KH is nothing but equilibrium constant, right? What is the hydrolytic constant? It is nothing but equilibrium concentration of ammonium hydroxide. Equilibrium concentration of ammonium hydroxide into equilibrium concentration of H plus ion divided by, since I have included water with this constant, okay, I can write directly ammonium ion here. So equilibrium concentration of ammonium ion at equilibrium, right? Ammonium ion at equilibrium. Okay, we should include water here. Since water is always taken as excess, the concentration of water remains constant. That constant is included here. That's why I wrote the constant directly as KH. Okay, so KH is nothing but hydrolytic constant, right? It is actually equilibrium constant into the constant or water concentration, right? Water concentration is roughly constant. Therefore, equilibrium constant into the concentration of the water is taken together and it is given as KH. KH is the hydrolytic constant of the salt. Okay, now I'll take this as equation number 1. Now what I'm going to do, KH equal to, what is the equilibrium concentration of ammonium hydroxide? HC. What is the equilibrium concentration of H plus? HC divided by equilibrium concentration of ammonium ion is 1 minus H into C. Okay, what is H here? Yeah, we have taken 1 mole of salt. Therefore, this H is called degree of hydrolysis. Right? You know very well. Depending upon the number of moles you have taken, okay, we'll give different symbol. If you take 1 mole, then we give H, the symbol H. What is H? H is called degree of hydrolysis. H is called degree of hydrolysis. Okay, degree of hydrolysis. Now what I'm going to do, I'll just introduce, okay, I'll just cancel this NC, right? So I'll just simplify this equation first. So we get a simplified equation of which looks like KH equal to H square C by 1 minus H. This is the complete expression for hydraulic constant. If you know the value of H, yes, you can calculate the value of KH. Okay, suppose if H is very much less compared to 0.1 or less than 0.1, if H value, degree of hydrolysis is less than 0.1, right, then 1 minus H, since this is less than 0.1, I can say 1 minus H is approximately equal to 1. Therefore, in the place of 1 minus H, I am going to put 1. So, I will get KH equal to H square C by 1. This is valid. This is valid for most of the salts. For most of the salts, hydrolytic constant, degree of hydrolysis will be less than 0.1. So, this is valid for most salts. So, blindly you can write this expression, right? Okay, without any confusion. Now, what is H from this? Bring this C here. So, you will get KH by C equal to H square, or H is equal to square root of KH by C. This is the expression for degree of hydrolysis. Okay, then in this reaction, we get a weak base, ammonium hydroxide. This weak base also undergo ionization. So let me take that first. Let me take that ammonium hydroxide is a weak base which undergo ionization and gives its ammonium ion and hydroxy ion. All these are present in aqueous medium, right? Now for this we can write the equilibrium constant Kb. Since it is a base, weak base, I'll write equilibrium constant Kb as concentration of ammonium ion at equilibrium into concentration of hydroxide ion at equilibrium divided by concentration of ammonium hydroxide at equilibrium. These are all equilibrium concentrations of ammonium hydroxide, ammonium ion and hydroxide ion at in the hydrolysis reaction. Okay, when ammonium hydroxide undergoes ionization, you'll get these ions. So if you write the equilibrium constant, you'll get equilibrium constant expression like this. Let me take this as equation number 2. Now what I'm going to do, actually we have to rearrange and substitute, or otherwise you just multiply equation 1 and equation 2. So I'm going to multiply left hand sides separately, okay, left hand side separately and right hand side separately. Okay, so what I'm going to do, I'm going to multiply equations 1 and equation 2. So if I multiply left hand side, I'll get KH into KB equal to, now if I multiply right hand side, okay, first I'll write once ammonium hydroxide H plus divided by ammonium ion. Remember, all are equilibrium concentration. I didn't put equilibrium symbol here. Into this concentration ammonium ion hydroxide ion divided by ammonium hydroxide. Okay, this is KH expression and this is from KB. Now you can cancel ammonium hydroxide, you can cancel ammonium ion. What we left with is H plus into OH minus. Okay, so KH into KB, let me write in the next page. KH into KB is equal to concentration of H plus at equilibrium into concentration of OH minus at equilibrium. Okay, and you know very well the product of these two is what we call as ionic product of water. Okay, so this is nothing but KH into KB equal to KW. What is KW? KW is nothing but ionic product of water. Okay, ionic product of water. Simple. From this we can say that KH is equal to KW by KB. This is the expression for hydrolytic constant of a salt formed by strong acid weak base. Okay, since the base is weak, we are having KB value here. Okay, now we also know that KH is equal to square root of H from the previous page, yeah, H is equal to square root of KH by C. Let me write here, H is equal to square root of KH by C, right? In the place of KH, if I substitute this, we get H is equal to square root of, in the place of KH I'll put this, so we'll get KW in the numerator divided by KB into C. Okay, this is the expression for H, hydrolytic constant. I'm sorry, degree of hydrolysis. Okay, so using this you can calculate degree of hydrolysis of a salt, right, of a salt dissolved in aqueous solution. Now how to calculate pH of the solution? Right, very simple. See, pH of this solution is due to this H plus ion produced. Okay, because of this reaction you will get H plus ion. This H plus ion concentration, okay, is responsible for pH, and H plus ion concentration at equilibrium is equal to Hc. So H plus ion concentration at equilibrium is equal to He into C, and we know very well H is equal to this, so square root of KW by KB into C. Okay, this C, if I bring the C inside square root, you will get C square. C square by C, if you cancel, you will get root of KW into C by KB. So this is the concentration of H plus ion at equilibrium. Okay, then what is pH? pH is nothing but negative logarithm of, let me write in the next page. So what is pH? pH is nothing but negative logarithm of base 10 concentration of H plus ions at equilibrium. Okay, minus log base 10. Concentration of H plus is, yes, it is available now. Concentration of H plus is root of Kw into C by Kb. So I can write this root as 1 by power 1 by 2 Kw into C by Kb. Okay, I'll bring this 1 by 2 in front. So I can write this as 1 by 2 or minus 1 by 2. Okay, let me write 1 by 2. 1 by 2 into negative logarithm of base 10. We'll get A into, I'll take this as A, this as B, and this as C. So logarithm of A into B by C can be written as log A. Right, in front we have minus sign, so minus log Kw minus log C. Then here we have minus, it is in the denominator, so minus of minus become plus, plus log base 10 Kb. I have written directly, that's all. Right, what is negative logarithm of Kb is nothing but pKw. So 1 by 2 into, this is nothing but pKw of water, and here we have negative log of C, here we have plus sign, so I can write this as minus log Kb base 10. If I write like this, okay, nothing going to change. Okay, minus or minus become plus only. Why I am writing like this? Because negative logarithm of Kb is pKb. So I am going to make, or I am going to bring a pKb expression here, or pKb symbol here. That's the reason. So pKw minus log C. Okay, this is nothing but pKb. We have minus sign in front, so minus pKb. Right, and we know very well at 25 degrees Celsius, okay, pKw of water is 14. So if I put 14 here, you'll get 14 minus log C minus pKb. Okay, so if I multiply by 1 by 2, I'll get pH equal to, okay, first I'll write once, pKw is 14. Okay, then I'll take minus common here, so 1 by 2 into pKb plus log C. Okay, what I did is, see, I substituted pKb values here. pKw is 14, then I multiplied this with 1 by 2, so 1 by 2 into 14, and here I took minus sign as common and I multiplied with the half, so minus 1 by 2 pKb plus log C. Right, so if I divide this by 2, I'll get 7, so the pH equal to 7 minus 1 by 2 into pKb plus log base 10 C. Okay, yeah, this is the expression for pH. Let me rewrite here. So what is the expression for pH? pH equal to 7 minus 1 by 2 times pKb plus log C, where C is the concentration of the salt, molar concentration of the salt. So if you know molar concentration of the salt, and if you know the value of pKb, right, add the two values, divide the value by 2, and then subtract that from 7. Therefore for this solution, pH value will be always less than 7. Since pH is less than 7, okay, the solution is acidic, so the salt is called acidic salt. Ammonium chloride is an acidic salt. Why? Because if you dissolve the salt in water, okay, the aqueous solution become acidic. That's the reason why we say that the salt is acidic salt. Right? Yeah. So let me just rewrite everything, all the expressions. So what is the expression for KH? KH is equal to H square C by 1 minus H this is the expression for KH. You can also write KH as KW by KB. Okay, you can write like this or you can write like this. Both are valid, right? And when degree of hydrolysis is less than 0.1, okay, under this situation you can write H is equal to root of KH by C. Okay, this is also valid because for most of the salt I have told you degree of hydrolysis will be less than 0.1. Okay, under this condition you can write H is equal to root of KH by C. Okay, then after finding this you can find the value of pH. So what is the pH? The expression for pH equal to, remember, for acidic salt pH should be less than 7, so 7 minus should come. Okay, minus 1 by 2 into pKb. It is a salt of strong acid, weak base. Base is weak, so you should put pKb plus log based on C. Okay, this is the expression for pH. So if you want to calculate pH of a salt formed by strong acid and weak base, you must know the value of pKb and you must know the value of concentration. Okay, yeah, so we'll do problems based on this as we go along in this lecture series. I stop here. Thank you for listening.